So, this is your basic 3D printing workshop all the way up to advanced 3D printing. So you're going to learn today how to use all the BTU printers, but also how to use some of the more cool and special ones. So let's get started with the boring stuff, which is that you should definitely scan this QR code and join our club. Because without this club, this workshop may not have been held. And we are bringing opportunities to many students to learn about Blender and 3D modeling and 3D printing. This is my plug, and I promise I won't talk about it anymore. But feel free to scan the QR code, join our Discord, and do whatever else you'd like. We're going to cover a lot of stuff today, but we're basically going to talk and cover FDM printing, a little bit of its background, how all of this stuff kind of works, and then we're going to start talking about how to actually use and do this stuff so that by the end of this, you're a 3D printing pro, and then we'll do a more in-depth demo later. So before we start, everyone probably should have Prusa Slicer downloaded on their computer. Feel free to do this in the background while we're actually talking about all of this stuff. It's not super urgent that you have it immediately. But just get it downloading, make sure it's ready so that by the end of the workshop, we can work with it on our own computers. I'll give people just a second to get that going. You do need to use Prusa Slicer with all of these machines because they are Prusa printers. We like to try to enable that consistency, and there's, in my opinion, not really a good reason to use anything else. So yeah, let's move on. So how would everyone describe 3D printing to each other? Let's all talk in tables, share some knowledge, share what you know, so that when we start talking about this, you can say, hey, I was right about this, or hey, this is interesting, I didn't think it was like this. So 2 minutes talking your tables. How do you envision 3D printing?
I mean, 2D.
Get out of the club.
Continue.
Get out.
Please continue.
You say 2D in this space.
God damn it. I'm trying to open the Prusa Slicer exe and it is crashing my computer.
That's not good.
It's the installer too.
Excellent.
Jeff,
stop jabbing, dude. I have it on my remote desktop.
Oh. Okay, I forgot that art's recorded at 7.
Oh yeah, you gotta get
Yeah,
Bye. Cool. Okay, let's log back in. Let's talk about it. Hey. So, this is a term you're going to hear used to describe 3D printing a lot. Fused deposition modeling, or FDM, is currently a patented term, but a lot of people use it to describe the fact that we are fusing layers of plastic together and melting them on top of each other, depositing these plastics, again, on top of each other in stacks, and then printing via that process. Fused deposition is kind of the main part of it that you got to care about. And there are a lot of other examples of things that are kind of similar to this thought process, which includes like a glue gun. If you ever used a glue gun, you can stack glue on top of itself. Frosting packets, you can make like cool little frosting creatures on top of cupcakes and stuff like that. Play-Doh rolls. I don't know about y'all. Whenever I was a kid, I would roll out big things of Play-Doh and then make a little cup, which I don't know how common that is still in like clay, but that's what I did. So you can compare this to a lot of existing stuff, but the most pertinent is glue gun because you're heating up a plastic in order to get it to stick and to do that deposition and fusing. One of the most important things about 3D printing is dimensions. So you got to remember that when we're talking about dimensions in algebra and in non-like 3D math, you're thinking about the X and Y plane. Now that's actually sat down on its back like this, how you wouldn't normally anticipate it. You're normally seeing it flipped up on your screen or paper like this, but we're focusing on this X and Y dimension here, with then the third dimension being the Z dimension, which goes strictly up and down. And again, they're stacked and fused on this Z plane in this manner. So this is a Benchy, which is unfortunately a model that's on its way out for complicated reasons. But you can see we've got these layers, these really thick layers that we have that we're stacking and making to make this shape. So we're taking this two-dimensional cross-section and we're showing these layers off. And that's all it really is. It's really not too much more complicated than that. I mean, it is, but you don't have to think about it much more complicated than that. The main thing you're thinking about is the extruder. So this is the glue gun, where essentially the nozzle is the tip, the heat sink is the heating element, and then the rollers and the gears, the things that are pushing this through, are your finger, where you're squeezing the glue in, pushing this filament glue through to get it to heat up and then pop out of the nozzle at a specific diameter. So here are some of the common nozzle diameters. They are 0.2, 0.4, 0.6, and 0.8, with 0.1 way the most common and what we use on 90% of the printers in here, with the exception of this one. So generally, you're going to be using a 0.4 nozzle. The extruder, you don't have to touch it, you don't have to worry about it, but that's how it works. This is how it exists. Then there's the bed. So I'm going to take this bed off real quick. The bed is hot because if you've ever used hot glue and you've accidentally spilled it on your table, for a little while it'll be stuck on there, but then a little after you start to pick it off. It's because it's cooling down, it's not sticking to the bed as well as it used to, which is why hot glue kind of sucks, because once it gets cold it starts to lose its sticky. So the bed has to stay hot for that reason, and that's where all the stuff happens. It all happens within this bed. So you've got an actual hot bed right here, and then you've got a plate which goes on top of that, which is where the plastic actually fuses onto. And the nice thing is that this is flexible. So when you actually pry off your prints, you can flex them off. Depending on the bed you have as well, some actually will just straight up self-release. So once they cool down, your print will just come off. It's kind of great. Sometimes you need to put glue on the bed in addition to the fact that you're already putting a glue-like substance onto it, because plastic doesn't always stick very well, believe it or not. And we'll cover that later. But in, like, again, 90% of your use cases, you don't really need glue. Here are kind of the two main materials you should know about, PLA and PETG. PLA is a cool material because it's actually pretty reasonably sustainably sourced. You can make it from a lot of really easy to get, well, I guess not easy to get, but like non-environmentally horrible materials like corn and sugarcane. You can process it very heavily and turn it into PLA. It doesn't really have an odor. It's 100% safe to hold. You know, you don't want to eat it because it's plastic. You don't want to eat any plastic, but like if you got it in your mouth, like not a huge problem. It's got a pretty high tensile strength, which means that it's rigid, but it'll shatter when it does break. Another thing is that it's got a low melting point, so it's very easy to print with because your printer doesn't have to get all that hot to actually print it. But the thing is that it can be a bad thing, because when it gets in the sun, it might melt a little bit after, granted, a very long amount of time. And it also will degrade in the UV light and heat. PETG is similar. I don't know exactly how it's sourced, but I know that it's really easily recyclable, which is good. Also odor-free and 100% safe for handling. It has a lower tensile strength, but with material science, that means that it's slightly more elastic, means that it won't shatter quite as bad when it does break. It's got a higher melting point, and it will still degrade in UV light and heat, but it's more resilient in these regards than PLA. We do, again, 90% PLA in this workshop, but PETG is a good option if you want a slightly more heat-resistant print. You want something that's a little tiny bit more flexible. It's good. It's also shiny, naturally, which is kind of weird. This is not necessarily crucial to your ability to use these printers, but there are kind of two big movement-style printers right now. Bed slingers, which I can show you, is literally just, it's moving the bed back and forth to achieve Y-axis motion with X-axis motion and Z-axis motion going like this. And then a Core XY machine, where the nozzle goes forward, backward, and left and right in a little square gantry, and then the bed actually moves down. We don't have any Core XY printers here yet. I hope we do one day. Right now, all we have is bed slingers, but it's kind of a cool thing to think about, especially because if you have a bed slinger printer and you get a really tall model, if you think about it, think about those architectural diagrams where you see a tower that's being shaken from the bottom. You can get prints that fall over because they're just getting shaken too much at the bottom and then coming loose from themselves. So just something to think about, not something that's super important to your workflow right now. There's also this kind of a cool thing called input shaping, which is a means of modifying G-code to accommodate printer vibrations. I don't fully understand how it works. I think a few people at Prusa do. It's useful for if you want to do prints that go really fast. The Mark IVs, we have it intentionally turned off because we found that it's actually sometimes a little more reliable to have it off, even if it's a little slower. The Mark IVs, like the ones that are in that cabinet that belong to CU3D, have it on by default and we can't turn it off. So it is faster on the Mark IVs, or the Mark IVs, but generally we have it off on the BTU printers. But it's cool. It can reduce these ringing lines right here, which can be kind of annoying and get you some better results. So something to look at if you're interested. So now that we did all that, let's actually load some filament. Everyone can come gather around me over here, where we will practice loading filament. Slicing. Cool. So here's my Prusa slicer. I see your computer looks like that. Let me bring up that window. So when you install it for the first time, what you're going to be greeted with, and if you already have it installed, follow this step. Let's go to the printers over here and hit Add Remove Presets. So we're going to load up this configuration wizard, which I'll walk you all through right now. And it says, welcome. We don't care. You're logged in. I'm logged in on my account. Configuration sources. So if all you're doing is using printers here, click this Prusa FFF. Again, that's the other acronym you can use to describe FDM. So let's click that. If you have your own printer, like that is not Prusa, you can click other FFF and it'll bring up like a lot of presets that you can use for your printer. SLA is resin printing, which we don't have here, but if you have a resin printer, go for it. We're just gonna do Prusa FFF right now. Downloading something. So I will walk you through all the printers we have in the BTU. In the BTU, we have 3 Mark IV S's, which are a high flow 0.4, a high flow 0.6, and then a Mark IV with a multicolor system with a 0.4 nozzle. But that's not really important if you don't plan on using these printers. The BTU ones are all pretty much here in the bottom. In the Legacy Profiles family, we like to use the original Prusa Mark IV profile with this 0.4 nozzle here, the original Prusa Mini and Mini Plus profile, 0.4 nozzle again, and then somewhere in here we find the Mark III right here, which is the original Prusa i3 Mark III's and Mark III's Plus profiles, again, 0.4 nozzle. Those last 3 that I just showed you, the Mark III, the Mark IV, and the Mini, are the like BTU printers and the ones that are like the easiest to use. So those are the ones that I would recommend having in your profiles. All of these profiles are also on the computers, so you don't have to slice on your computer. We're just doing that for the sake of today. But the one that I want to make sure we all have right now is just this last like original Prusa Mark IV profile. It's going to make our lives the easiest. So we're going to hit next. This doesn't matter. You can hit next. Filament rolls, you just want essentially all of the generic ones. So like find the generic thing in here. You want all these clicked essentially. The ones you care about the most are PLA, PETG, and probably Flex. Flex we'll talk about a little later. This doesn't matter. This you can do if you want. This you can do if you want. I would recommend doing this. And I would do expert mode. Why not? Let's make us all experts today. So once you've done all of that, you will see our slicer. So this is the bed, if you can believe that. This is exactly the same size as our bed would be on the printer, so you can use this as a scale reference. I mean, not on your screen, but like this is the Mark IV bed. It wants you to add something first, so let's do that. We hit this little add button right here, and let's go to my downloads. Let's add this thing. Sure, why not? Look at this cool little part. You can see we just got a lot of tools opened up on our side though. So we have a move tool, move stuff around the bed. A scale tool, very useful. We can scale things. We can also scale them in certain dimensions. We can make them all squishy and up, but we're not going to do that. There's also a rotate tool, can be very useful, and you can use these little clickies to click it around or move it around fluidly. One of my favorites is the lay on face tool, which means that if you have a print that you know has a flat side, it'll guess where those are and click them, and now it's laid flat like this. This would be great right here. There's also a cut tool, which I never really use, a paint on support, which I never really use, seam painting, which I never really use. Fuzzy skin is cool, don't really use it. Measure if you need. There's also some more up here, which is adding more objects, subtracting objects, removing objects, arranging. I always just hit A. Before I start a print, I always hit A. A is great because it just puts the print in the center of the bed, which is good because the heater is in the center of the bed and you want the print close to the heat. There's also some things that I don't really use. So that's this window. Over here are all of your printer settings. So on the Mark IV, you have some settings including ultra detail, speed, draft. The number you care about is the layer height. If y'all remember that picture of that boat, those slices, that's what you care about. So we're doing layer height. We're thinking about layer height. I will tell you from many a year I've experienced I have at this point, 20 millimeter speed is the best for everything. prototyping, final drafting, you really don't need anything else besides this. So you got your print setting selected, great. Then you want to check your material. So what are we using? Generic PLA. We click generic PLA. Just because it's orange and this is black, don't worry. Doesn't matter. If you want to change the color, you can make it whatever color you want. Let's make it pink. And then, of course, there's the actual printer you care about. I have a huge list, but what are we using? The Mark 4.4. Those are those printers over there. Great. That's all we care about. So we want to make sure that is clicked. Now, the interesting thing are supports. Has anyone ever used or thought about print supports ever? A little bit? Okay. So let's find something that could use supports. If I right-click it, I can find a little gallery of things. Let's do this bunny. And the printer could probably get away with this, but this geometry, do you see how this is kind of just like hanging out in space? Sometimes if you print stuff with this kind of geometry, it can just fall and look ugly and fail and be terrible. You need support. You need a thin lattice like scaffolding structure to support this such that when it starts to get to here, it will have something to print on. So supports, I say turn on supports everywhere. The other options are build plate only and support enforcers only. I say everywhere. Everywhere is a good option in general, and I can explain why later, but I would just do everywhere for now. So supports are on. If we were to slice this, we would see, look at that. These green things, that's support. This breaks away very easily. It uses a very low amount of filament. It's a great way to make sure your print turns out good. And we can see a lot of other cool data, like that this is a 5-hour print. Reasonable enough. 5 hours is good. That's not too out of the question. Now let's do a different model. If we were to have, I don't want a cylinder. I want something else. Let's think. A screw. Why not? Let's say that this screw, for some reason, you were printing this screw. Please? Okay, never mind. That doesn't work. Let's say you're printing this screw like this. Horrible idea. Don't do that. Horrible idea. But if you had to for some reason, look how small of a contact area this has on the print bed. Very small, very bad. Because like we talked about, since this print is moving back and forth so much, and every time it's printing on top of itself, it's dragging on itself, this thing's going to come off the bed, and it's going to become a spaghetti monster. You don't want that. If we were to slice this, look at this bottom layer. It's like, that's because we have supports on. Let's pretend we don't even have supports on. That little yellow bit, that's the only thing touching the bed. You think that's going to stay? I certainly don't think so. That's where you would use a brim. So if you have an object that you know has a very small footprint on the bed, a brim will save your life in terms of it'll add plastic to give it a little foot. Look at that. It has a little shoe now, and it sticks to the bed a heck of a lot better. So again, don't print this like this. But if you have a small surface area, a brim can be the difference between a great print and a failed print. That's all you really need to know. Yes?
How do you do tree supports?
Okay. It's an interesting question. Tree supports. What makes you interested in tree supports?
Because at some point I heard that they were good.
Okay. Who told you they were good?
I don't know.
Okay. So, tree supports are cool. They're not always better. Do not let people convince you that tree supports are always better. Case in point. If I was to gallery. If I was to I don't think there's a good example I could pull up necessarily. Tree supports, if you want to do them, I fully support the idea because I use them every now and then. They're quite good. You saw how this looked when we had supports, right? Let's do it again. These are just like straight up and down, right? And this filament cost is 94 grams. So to use tree supports, we go in print settings right here. This is like a super expanded view of everything we were doing up here. So this is where you can mess with everything. You go to support material, style, organic. If we slice this again, how was it, 94 grams? Cool. That looks pretty freaking cool, right? Saved us 4 grams. You know, it's cool. It won't always save you filament. In this case, it would, but it won't always. And sometimes tree supports are actually more difficult to print than regular ones. So yes, experiment with them at your own risk, but know that they are not always a end-all be-all better solution. A lot of the time they can save you filament, but some of the time they don't. And some of the time they're honestly just more hassle to remove than they're worth. Because they are sometimes a lot harder to remove, believe it or not. Leo, please.
Sometimes they also add like an extra 30 or 40 minutes
Yeah.
for some reason.
It's just a different style. So try it. I encourage you to try it. Find out what works best for your print and experiment. We're all about experimenting. But I'm glad you asked that. Tree supports are cool. They also just kind of look cool, which I can't lie about. Cool. So if we were to go print this on those printers, what we would do now is one of two things. If you're on those computers, you can just straight up say send to connect and choose your printer. You can see all of these ones are printing right now. It says they're finished, but that's actually not true. They're all printing right now, so they're just lying to you, which is kind of cool. And you would say here we go. They're printing. There you go. So like Beetlejuice, they all have name tags now. So like Beetlejuice is the middle one. Beetlejuice is printing, but if it wasn't printing, you would click on it and you would say set ready and print now, and it would just send over the cloud. But that's if you're on those computers. Alternatively, you can also just take a thumbstick, which is stuck right in the side here, take that, yank it out of the printer gently, put it in your computer. So I'm going to put it in my computer, and I'm going to say export G-code, and I'm going to say Prusa Mark IV. You can see all these files that already exist on it, and I would say save. It would say I'm exporting binary G-code. That's okay. I can explain what that is if you're interested. And then please, for good computer hygiene, remember to eject your drive. Then you would take it out of your computer, put it in the printer. This one's going to freak out because I'm slicing it for a different printer. It might not freak out, actually. It typically auto-populates with your file. So you can see I got my little bunny right there. Oopsies. I can say print. And as long as the bed is clean, do your homework. Make sure there's nothing on the bed before you start printing. Filament's loaded, bed is clean, start your print. Very easy. Yes?
Do you need to do anything in particular to clean the bed if someone else has printed and then taken their item off, there's nothing visible on it?
Yell at the person to clean up their bed? No, not necessarily. I mean, so the bed normally won't have anything on it besides plastic. And so if there's little bits of plastic on there, tell the person to clean up their darn bed. But also you can gently kind of push it off because it won't stick super hard. We have little plastic scrapey tools in there, but everything should come off just by being able to flex it off. So you would basically just do this. I see your hand. One moment. Yeah, so you would just do that. Now, for the advanced section, we'll talk about that in a couple minutes. But Ash, what do you have, please?
Oh, I was gonna say a lot of people keep leaving the first when it wipes its nozzle. A lot of people keep leaving that on. What?
Take that off for good luck.
Yes, and for not running the machines.
Do y'all see this green line right here? That's what Ash is talking about. That is a little purge nubby that it spits out to make sure that the filament's coming out okay when it starts printing. People forget to take that off, and it can start to accumulate and get really gross, and can also cause your print to fail if you just have like a huge glob right here. So make sure you take that off. Now, if the bed is so clearly covered in fingerprints that it looks horrible, what you want to do is basically, I'll even demo this. Grab a little bottle of isopropyl alcohol, which are labeled as such. Don't worry, it's not going to hurt the printer. It's only going to hurt your nose. Not actually, don't worry. Put a little bit on there. Take a paper towel. Yoink. Wipe. Wipe off those fingerprints. Oil can cause adhesion issues. You'd need a lot of fingerprints for it to be a problem. It's good practice. It's good hygiene. Hope that answers your question.
Yes, it does.
Okay. For those of you that only care about BTU printing and not trying more advanced stuff, you have completed the 3D printer training and are now ready to 3D print. The other printers, like the Mark IIIs and the Minis, load filaments slightly different than this, but it's the same process. You just have to, with the Mini, you have to push it in a little bit more. Just if you click the load filament button, there's generally a pretty good prompt on the screen that tells you what to do, and I can show you that if you want, but it's not too hard. A lot of people know how to do it, so you can always ask. So, you are free to leave at this point. Now, if you're really cool, we get to go to the interesting stuff that I haven't talked about in the BTU yet, really at any workshops. So, Does anyone have any questions before we move on? Okay, let's get interesting. We already did this. Advanced printing is a new topic we were introducing as of like this year. Flexibles. Who here has heard of TPU? Yeah, here and there. TPU is I think the hierarchy is it's a kind of TPE. TPE being the greater term that describes them. It's essentially a flexible plastic, and it's weird. One moment.
Why does he do that? Why does he run like that? That's just whimsical man.
TPU. This is Alan's TPU. It's a noodle. Feel that. Isn't that weird? How does that feel? Look at that. That doesn't feel like PLA. Here, go for it. Not gonna bite. Yeah. Alright. Weird. Yeah. TPU is a kind of TPE of which is measured on a shore hardness scale. You can look that up later, please. Which refers to how hard it is basically on a scale of 0 to 100. You tend to find TPUs or TPEs between 65 and 95. 95 is this, so you just felt how soft this is already at 95. So once you start to get below 80, it's literally like a limp noodle, and it's very hard to print with. TPU 95, you can print on these printers without having to change anything. If you need to start printing super soft plastics, that's when you have to start adjusting these springs, which is still a very experimental topic for the BTU, so it's something we're willing to investigate. Problem with TPU, you can't put it through tubes because it's grippy. It's rubbery, so it'll grab onto the tubes and it'll mess up your print. But it does work on these printers because it just goes straight in the top. Also, these materials tend to stick too well to the bed, which is why you use glue. What? Yeah, it's stupid. It's a stupid sentence, but it's true because, believe it or not, Elmer's glue, regular glue, works as a great release layer for TPU, meaning that if you have your bed and you print without any glue, they'll lock hands and then you'll get horrendously destroyed beds. The glue acts as like a nice mattress for the print to sit on and still stick to without coming off, such that you can basically pry off the print and the glue, but not the bed. So you use a stick of Elmer's glue mixed in with a little bit of water. So get like a couple drops of water on your fingers, mix it around, get a nice thin layer of that Elmer's glue on the bed whenever you're printing with TPU, and you're good. In the slicer, it's called generic flex. So you'll see flex, that's TPU. And generally, the printer we use the most for TPU is U3D Suzanne. So feel free to do that. Suzanne has proven time and time again that she is capable of doing TPU, and we love her for that. So that's flexibles. Any questions? We encourage you to try it. It's very fun. High temperature materials. This is Alan's category, so I can go ask him questions after this about what he's done with that. It's Alan. High temperature materials includes things like ABS, ASA, nylon, polycarbonate. I like to call ABS the McDonald's toy plastic because it's indestructible when it's like exposed to the elements, but otherwise kind of cheap. ASA is a version of ABS that's chemically different, very cool. Nylon, very hard to print with, but it prints at like 300 Celsius, 290 Celsius, which is crazy. These are all materials that print at like near 300 Celsius, which is insane, which gets this printer very hot. And when they print, they are also so thermally messed up that they start to, like if you have like a flat like plate thing like this that you're printing, it'll start to warp up like this around the corners and contract it on itself. Therefore, you need glue. And we actually have some special glue for this. There's a green bottle. There's also this bottle of Magigoo, which you have to slam against the table to actually get it to start coming out. But otherwise, it's like a little pop marker. So you use like a pop marker. And I'm also trying to convince Zach to buy some of this. This is just, yes, Alan agrees. This is good. You just put a few drops on the bed and you paint it on. And it's a really good glue for sticking these materials on there. Expect to fail with these sometimes. They're a lot more volatile than PLA. And all of this is done on Icarus because we love him for his dedication to being our high temp printer, and also because this metal bed is a lot better for it than the metal and plastic beds that are on the other printers. Then there are abrasive materials, which kind of fit under that high temperature printing category. These include things that are not just filament, but also filament with stuff in it. So this is like carbon fiber infused filament, which is a crazy term. Also glass fiber infused filament. I call that the new asbestos. Don't touch it. You don't want to get your hands on that. These things are mean to nozzles because those little shards of stuff are constantly brushing up against the nozzle and just kind of expanding the heck out of it. Therefore, you need to use a steel nozzle printer with that. Again, Icarus is our boy when it comes to that. He's the only printer fitted with a steel nozzle. The rest of them have brass nozzles. These materials are strong as all heck. But they also struggle with adhesion. They also are just more volatile to print with. And they are very challenging overall to use. But the results you can get are really cool. Look at this. Like, normally you see the layer lines really aggressively with PLA. They start to kind of disappear when you use PLACF, which is really cool. And they also have a really cool matte finish. They're really pretty filaments. Again, all of this is on CU3D Icarus, and we encourage you to talk to a printer wizard in the chat if you would like to do so. Yes, Alan?
I will also not recommend printing carbon fiber infused filaments here because they will actually spit out bits of carbon fiber. And that happens with all materials, but it's not good to inhale, especially the carbon fiber.
Excellent.
I think you said Prusa is the only one that has like.
They're the safest so far. A lot of companies have not done very thorough safety testing on these materials. So buy Prusa PETGCF. It's the safest we've found so far. It's a very much an uncharted territory. Talk to Alan, basically, if you want to do that, because Alan knows the most out of all of us. And then this is the topic we are most excited to talk about this semester, which is multicolor printing. We have a new printer this semester called CU3D Bob, which can print with 5 colors at once. Only one nozzle, but 5 colors that can go into that single nozzle, which means that you can only use one type of material going in. So what I mean is you can have 5 different colors of PLA or 5 different colors of PETG. You can't have red PLA and blue PETG because when you try to print the different chemicals in the same nozzle, it tends to clog the nozzle really badly and leads to really terrible results. It's a territory that is still expanding. There might be a point when you can do multi-material on a single nozzle. People have found varying success with it when they experiment with it. For now, it's not a very good system. So really, we rely on using only one kind of material, multiple colors of it in Bob. And then after we finish this presentation, we'll go over to Bob and do a demo of how to load filament. Leo, yes, thank you. And really quick, to finish us up, I will show you how to paint things in Prusa Slicer.
What?
I know.
Can you show them how to cut it in half?
Cut what in half?
A lot of times people do the thing that's 2 objects in one pile. So one's there and one's floating, and you have to kind of separate them.
Oh, I can show them that if you'd like. So, if we're gonna paint something, we need to have a printer that can paint. So we're gonna grab this original Prusa Mark IV's MMU 3.4 nozzle, mouthful, right? Grab that, discard, and then you can see we get this little weird object added to our bed. That's the purge tower. That's how it changes color, because it has to spit out a little bit of filament every time it purges. It's a heck of a lot less wasteful than certain other printer manufacturers out there these days. So what you're gonna do is you're gonna make sure you've got your file. We're just gonna use this Benchy. I like, for my sake, to assign the colors up here to what we have in the printer, which I happen to know is black and yellow and white and orange and green. Weird color combo, but it exists. And then all of the painting is contained within this little painting tool down here, which you then zoom in and you get all kinds of cool tools. And so you have 2 colors. You can use it once. So your left click and your right click. I'm on a trackpad, so I'm only gonna use my left click. So we can brush color on. Whoa, look at that. We're painting a little smiley face. Woo, look at that. Oh, it's horrible. Try again. There we go, look at that. Isn't that cute? So we do that. We can also do a smart fill, which is dependent on the angle between the geometry. So a smart fill angle of 30 degrees would probably get cut off by an angle like this, but maybe not like this. So if we do a 30-degree smart fill angle, we can color in the bottom of the boat because there's a 90-degree angle here, but these angles are not quite as bad, so it'll work. Or we can make it less aggressive, maybe, and do just the bottom. No, that didn't work. Let's try it again. Just the bottom. Now you can see it got rid of, can I zoom? Oh my God. It got rid of the little trim here. So decreasing that angle can give you more precise results. So to increase the angle, you do all of it at once. But that's what the bucket fill is. It's basically just a full fill. There's also height range, so you can like color in sections. So now let's do that. And then maybe this. And then maybe orange, smart fill. Uh-oh, it's still set to 90 degrees. Look at that. Isn't that cute? That's how you paint. And then I would encourage you all to, if you would like to learn how to use the multicolor printer, to go into that room for a demo with Leo. And that concludes my section of the workshop. Harrison, you have a question?
Yeah, how deep does the paint go? Like, if you're just painting on the outside, how far in does it go?
Such that it can conserve as much filament as possible. It will infill with the same color you're printing on the outside, or some combination. So check this out. If I was to go down, see, it's like kind of a combo here. And this can kind of matter sometimes because if you have like a white outside and if you have a black inside infill, the black will show through and it'll kind of make your white look darker. So it's worth messing around with to actually change your infill settings. That's another thing I didn't really mention during this workshop was infill. I'm kind of surprised I didn't. Infill is the internal geometry of the print. You really never need to do anything else besides 20% or like 10%. That range is really fine. The thing that matters about infill when you can mess with this is the infill pattern, which I encourage you all to find out and mess with on your own time. And that's in this section, infill pattern. There are lots of cool infill patterns you can do. Ash also wanted me to mention cutting. We can split our model into 2 pieces. Perform cut. We have a 2-part benchy. Look at that. Now we could split up a really tall model into 2 pieces. Does anyone have any questions? Thank you all for attending my section of the 3D printing workshop. I encourage any of you who want to go learn how to use Bob to go in that room. Thank you. Thank you. Oh, you shouldn't. No, please.